Okay, geometry fans, our topic for today, this is section 1-2, line segments and distance. Two things we're going to try to accomplish today. After this lesson, students should be able to, 1, calculate with measures, and 2, find the distance between 2 points. Before we start, let me give you your joke of the day. The largest knight at Sir Arthur's Round Table was circumference. He got his size by eating too much pie. P-I, pie, 3.14. All right, good geometry joke there. Okay, so today we're going to talk about segments. And we mentioned it very briefly in the last notes when we were discussing points, lines, and planes. A segment contains two, and here's a blank, and we're going to write in the word end points, 2 endpoints, and all of the points between. Now the figure that we have below here, this is a line because it goes indefinitely in 2 directions. So if we want to talk about the line, we draw a line symbol above the 2 points A, B. That's what we use for a line. However, if we only want the 2 points and all the points between them, and remember, we can put an infinite number of places on this line. We're only naming 2 of the points. But if we want these 2 and including everything between, this is no longer a line, this is a line segment. And the way that we name a segment is the 2 points, but we just put a bar over the 2 points. We don't put arrows because it doesn't continue left and right. Now we can say AB, but we could also say BA because the order doesn't matter. Okay, so the whole thing is a line, but what we're talking about today are segments. And the endpoints would be point A and point B. It's the starting and the stopping. Okay, now you see a number line down here. There's 5 points on it. The number line is labeled from -5 to +5. Now, here's again, geometry is very specific with terminology, with symbols. It's like its own language. If I say DC and I put a segment bar above, then I am talking about the segment itself, the 2 endpoints and the points between. That is referring to the segment. But if I write DC without the bar, now I'm talking about the length or the measure of the segment. Okay, another word would be distance. So if you see this, don't be confused. It's asking us for the actual number length, the actual measure of the segment. Now the measure from D to C is 1, 2, 3. I can count 3 spaces. When I count from where I'm starting from, that's not 1, that's 0 right there. My first step is 1. So I don't include D itself, that's not 1. It's 1, 2, 3. Okay, so the length of DC, I would say DC equals 3. So example number 1, use the number line above to find the measure of each segment. Okay, so at DC, we just did that. Now again, this means length of DC. You're going to hear me say this. I'm going to put the word length or the word measure in front of these here. So the length of DC is 3. The length of segment CD. All right, now you're going to be tempted, if I start at C and I count this way, you will be tempted to write down -3. But distance is always positive. So it does not matter the direction that we go in, whether it's left or right, up or down. This is not a coordinate plane. The length is also 3. The length of CD is also 3. They're the same. Okay? D to C is 3. C to D is also 3 spaces. Okay, CA. From C to A is 2. And go ahead and pause it. You can do all of these here. And then unpause and see if we agree. The length of AB from A to B is 1, 2. The length of BE from B to E is just 1 space. That's 1. Okay, now we're going to add some lengths. We're going to add some measures. So the length of DA plus the length of AE. Let's see, so DA is here. 1, 2, 3, 4, 5. So that's 5 spaces. Plus AE. AE is here. 1, 2, 3. So the total length, 5 plus 3, is 8. I'm just adding these up. The length of DC plus the length of CE. The length of DC. So now DC, all right, we already have that one. That's 3. And from C to E is 1, 2, 3, 4, 5. So there's 3 and there's 5. Notice 3 plus 5 is also 8. Now we're going to do one more here. DC, the length of DC plus the length of CA plus the length of AB plus the length of BE. Whew, okay, so 4 segments. Now these are all the small ones. DC, CA, AB, BE. 3 plus 2 plus 2 plus 1. 3, 5, 7. Again, we get the number 8. Okay, and we're doing this for a reason. What we've basically discovered is something called the segment addition postulate. That in all 3 of these examples, we started at D and we finished at E. The length of the whole thing from D to E is 8. So no matter how I break it up, whether it's in red, notice that it's still the whole thing in red. If it's in green, notice that the whole thing is green. If it's in blue, notice that the whole segment DE is basically being highlighted. So it doesn't matter how I break it up. If I add the parts, if I add the smaller segments, what I get is the whole thing. If I add 3 and 5, I get the whole thing 8. If I add 5 and 3, if I add 3, 2, 2 and 1, I get the whole thing, which is always, in this case, going to be 8. And this gives us something called the segment addition postulate. Postulate is a rule that we assume to be true. A rule we assume to be true. Now, I'm going to draw this, okay? So we're going to draw it and we're going to write in words what's happening. So I'm going to start with the words. The official definition, if point Q is between points P and R, then the length of PQ plus the length of QR is equal to the length of PR. Now, one of the things about geometry definitions is they can be very confusing. They're going to get a lot longer than this with a lot more things going on, but you see all these letters here and an equation. We always want to draw so that we can visualize what's happening. Point Q is between P and R. So P and R are my endpoints. Q is somewhere between them, so I'll put a Q here. What the segment addition postulate says, we're adding segments. If I take PQ and I add that to the length of QR, then what we get is PR, which is the whole thing. The length of PQ plus the length of QR equals the length of PR. And as an example, let's say that the length of PQ is 10. Let's say the length of QR is 14. We can say that the length of PR is 10 plus 14, which is 24. Now, here's the official definition, but the way that I like to explain it, the idea is that if you add all the parts, you get the whole thing. Get the whole. If you add up the parts, you're going to get the whole segment. Okay? All right, so we're going to do a couple more examples here. Number 2, U-V-W. Now what that means is that V is between U and W. So I'm going to draw immediately. There's U and W, V is somewhere between them. I'm not putting V in the middle. That's going to be a different relationship for a different day. I don't want to assume that these are equal. So I put V either closer to U or closer to W. If the length of UV is 10, okay, so between U and V, I'm going to write 10 down. And the length of UW is 18. Now, U to W is the whole thing. So I'm going to draw, there are a couple ways you can draw this. I'm going to draw a bracket here that goes from U to W, that's 18. Now I've seen some students will just draw it kind of like this because this squiggly bracket is a little tricky. That's what I'm going to use. So it doesn't matter, but the key is you need to label your picture. You need to draw it and you need to label it. Now the question, what is VW? What's the length of VW? So what we need is this part. I'm going to label that with an X because I don't know what that is. Well, now you can get this in your head. You can look at this and you'll see the answer. But if I want to make an equation, I can use the segment addition postulate to say that if I add the two parts, 10 plus x, it's equal to the whole thing, which is 18. And now I can solve this. I'll move the 10 by subtracting it, and what we get is x equals 8. Now x is the length of segment VW. So I'm going to write this one more time. I'm going to say VW equals 8, and that's it. We're done. All right, let's take number 3, A dash B dash C. So what that means is point B is between points A and C. I'm sorry for this thing being cut off, or that little mark right there from the copier. The length of AB is x plus 3. So here's AB. I'm going to put x plus 3 there. The length of BC is 4x minus 5. Okay. I'll just label it like that. So here's 4x minus 5. And AC, the length of AC is the whole thing. I'm going to make that bracket. That's 33. Find x and the length of BC. So now we're going to do two things. Now this one we're probably not going to get by doing it in our head, so we're going to make an equation. Well, the segment addition postulate says if you add the parts, you get the whole segment. The parts are x plus 3. Okay, I'm going to put a big plus sign there, so that plus the other part, 4x minus 5, equals 33. Now we need to solve the equation. I'm going to just draw this. Here's my left side, my right side. Add like terms on the same side. 1 plus 4 is 5x. 3 minus 5, that is negative 2, equals 33. Move the constant, we'll go plus 2. So 5x equals 35 because negative 2 plus 2 is 0. To undo multiplication, we'll divide by 5. X equals 7. Now, we're not done because they also ask for the length of BC. So what I'm going to do here, I found x, but to find BC, I need to take my answer and I'm going to go back to my picture and I'm going to substitute 7 for that number. So I'm going to do 4 times 7 minus 5, and that's 28 minus 5. So this is 23. So the length of BC equals 23. Now technically I'm done, but if I wanted to check, I would also plug it into the other part. I would do 7 plus 3, which is 10. And the way that I check this is 10 plus 23 equal to the whole thing 33? The answer is yes. So I know for a fact that everything's right. So you need to solve it, go back to the picture and substitute, find the actual values, and then ask yourself if they make sense. And then make sure you answer the question. Okay, we're going to do one more here at the bottom. Number 4, they actually drew us a diagram. That's nice. Find x and the length of MO, that's the whole segment here, if the length of MN is 10x minus 7, so M to N, 10x minus 7. I label it between the points. I'm not going to put it over here at M. MO, now that's the whole segment, is 13x plus 13. NO is 8x. All right, segment addition postulate says we add the parts. So we add the parts, and that's equal to the whole thing. Here's the equation. Now to solve it, I'm going to add like terms. That's 18x minus 7 equals 13x plus 13. I want to get the variables on the same side. I'm going to move the 13x by subtracting it. 18 minus 13 is 5x minus 7 equals 13. I'm going to move the constant to the other side, add 7. So we get 5x equals 20. Then divide by 5, x is equal to 4. Okay, now it says find x and the length of MO. MO is here. I'm going to go back to the picture. 13 times 4 plus 13, that's 52 plus 13 is 65. So that whole thing is 65. Now that is the answer, the other part of the answer, but did we do it right? Well, let's go back to the parts and we'll substitute 4. So we'll do 10 times 4 minus 7. That's 40 minus 7 is 33. 8 times 4 is 32. Is 33 plus 32 equal to 65? Yes, it is. Check. And so we're good. And that is the end of part 1.